Hi, I'm Axel from FenceFast. We're here today to talk about energizers, energizer selections, energizer grounding. We deal mostly with Gallagher energizers for our energizer supply. They have a wide selection of energizers in different sizes. We have energizers all the way from 0.1 of a joule all the way up to 100 joules. Here we have an all-in-one solar S100, which is a 1 joule energizer. This is a Gallagher MBS 1800i, which is an 18 joule energizer. We can power these energizers up. This one will read about 7.7 right now. This one here, if we power it up, would read probably around 8 kV. They would read very similar kVs. The difference is their joule output. This 1 joule energizer would be equivalent, say, to a Ford Ranger pickup, let's say, going down the road at 100 kilometers an hour. This 1800i would maybe be the equivalent to an F350 diesel going down the road at 100 kilometers an hour. Now, if we load these up with 10,000 pounds, this Ford Ranger is going to probably just stop moving. Whereas with this F350, it still continue to go down the road at 100 kilometers an hour because it's a much more powerful energizer. So reasons we would choose different size energizers, animal type could be one. So if we're talking sheep, goats, things like that require a bigger shock, because they're harder to shock, we would want to start with at least a 3 joule energizer minimum. Whereas something like horses or cows, we might get away with a half joule or a 1 joule. A good rule of thumb for every mile of fence or 1,600 meters of fence, 1 joule of energizer is a good starting point. In heavy vegetation areas, it may be half that. In drier areas, we may get double that. But again, with something like sheep or goats, we'd want to have a 3 joule minimum and then move up from there. Another scenario why we'd want different size energizer is the distance that we're pushing. So if we're doing a long distance of fence, we would want a bigger pump or a bigger energizer so we could push that energy further. The other factor would be vegetation load. Think of a water line with pressure in it. Every time a piece of grass touches it, that's like poking a hole in that water line, and you're losing a little bit of pressure each time. So think of the pressure in that water line as a kilovolt. So energy and water act very similar. In water, we have the flow of water. With energy on electric fence, we have the flow of current, electrons. The more holes we have poked in that water line, or leaks from that fence in this case, the lower the voltage is going to go, because we're going to be losing pressure on that line. So in order to keep that up, we need to have a larger output pump or energizer. There could also be other factor leaks in that too, that, maybe there's a short in that fence that's bringing it down, or maybe we're using a fair bit of poultry netting. Poultry netting can draw a lot of leakage down on a fence because those wires are maybe touching the ground or the grass, and it's pulling that down. So that's why, again, we'd want a more powerful energizer to offset that. The other side of the energizer would be your grounding. So the way an energizer works is we have 2 connects on here. So the red one is our positive, the green one is our ground. If I just touch this red one with this energizer on, I'm not going to receive a shock because it can't close the circuit. I would have to touch both of these for it to close the circuit. So in an electric fence, for example, this would be connected to the hot wire in the fence. If I was to touch that hot wire in the fence, that shock would pass through me to the ground, across through the ground to the ground rod, back up the ground rod that would be connected to our cable that would connect to the ground side of the energizer, and that would complete the circuit. Without that completion, I wouldn't get a shock. Now, if I don't have enough ground rod in the ground, because this ground rod acts as an antenna, if I don't have a good enough antenna to accept that signal coming back across the ground, the circuit will not be completed. Also, if my ground is maybe not a good conductor, things like dry sand or gravelly grounds, for example, or very, very dry ground, can not be a good conductor, meaning that that circuit cannot be closed because the energy or the electrons cannot come across the ground to the ground rod to complete the circuit. In that case, we may have to go to what is called a pause-negative system. This means that we run pause-negative wires on the fence. So there's 2 wires, one connected to the ground, one connected to the hot side. So when the 2 wires are contacted on the fence, that closes the circuit. Testing of our energizers is another key as well. So if you have an electric fence, you should have at minimum a little 5-light tester or something like this so that you can test your fence system to see what it is putting out. Touching it or using like a standard voltmeter will not work. Your voltmeter will get damaged doing that. So make sure you have at least something like this. If you want something a little better, this is a digital voltmeter. This will actually read the output of the energizer and give you a digital reading. So if I turn on this energizer and I put the contact ground to the bottom and the hot here, I'm going to get a reading on this. And it's going to read, see if I can get this where you can see it. It's going to read, in this case, 7.5 kilovolts. So that's telling me what this energizer is putting out. This tester will measure amperage and kilovolts. So the kilovolts is the pressure on your fence. The amperage would be the flow of the electrons on your fence and or the current. If I have a leak, I can put this to the fence and it will show me in which direction that leak is and how big that leak is. If it's only 10 or 15 amps, it may just be vegetation load. If I'm up 25, 30, 40 amps, it's most likely I have a dead short on the fence, and that means something is, a wire's down or something's taking that to ground. I'm gonna have very high amperage and I'll have very low kilovolts. If my kilovolts drop below 3.5 kilovolts, then I don't have shockable energy on my fence for horses and cattle. For sheep and goats, I want to maintain, or even predators, I want to maintain at least 4.5 or greater on that fence to make sure I have an adequate shock available on that fence. Connecting is another critical part. So we want to make sure any connections that we're doing on our fence, that we're using clamps to ensure that those are a tight connection. Same with our grounding. Our ground rods, we should only be using galvanized ground rods in our system and galvanized stainless steel or aluminum in any of our wires in our connecting system. This wire here we have is our Gallagher high strain insulated cable. This has a double shielding on it designed for the high voltage that we're putting through it. It also has a steel wire with an aluminum outer core. Aluminum is 3 times more conductive than steel. So with the aluminum, I can pass in 3 wires, the equivalent of 3 wires under my gates or lead out to the fence, whatever it is. I use this on energizers 8 joules and greater. Under that, I generally just use the heavy duty lead out cable from Gallagher, which is a black cable and just straight wire. Doesn't have the aluminum coating. It's important to use this so you don't have any leakage on your fences or stray voltage, say going out through a building. And also again, if I'm going underground, I want to make sure this is shielded well. Lots of times even in a building or even underground, I'll put it in an additional conduit for extra protection as well. Last but not least is a very important management tool that we use a lot is cutout switches. So these can be installed in your fencing periodically so that you can go to the fence and shut down zones. This is very helpful in troubleshooting or isolating pieces of fence that you may have damage to or need to shut off for repair. Lots of different things, or maybe just shut off for the season. You're not using it through the winter, there's no point in powering it. You can shut it off while the rest of the farm is still heated up. If you have any questions, feel free to reach out to us here at FenceFast. You can find us online at fencefast.ca.